Hello and welcome guys. So this is my first video about Golang. Specifically, we're gonna build a chat application. However, the goal of this video is not to learn how to connect via WebSockets. There are plenty of videos about that. The goal of this video is to learn how to use Golang tools. Specifically, I wanna practice scenarios where we're gonna have race conditions or we need to solve concurrency, we need to build some kind of internal queue. So basically, we're gonna practice how we're gonna handle when a lot of clients are connecting at the same time, disconnecting at the same time, when messages are arriving at the same time, and all this happening basically at the same time. And I took inspiration from Socket.io, so we will try to build using their ideas, right? Obviously, I'm not gonna repeat the entire library, but the ideas are from there. So basically what we will use. Obviously, we will use coroutines, we will use channels, we will use channels with select statement to create queue-like behavior. We will use mutexes, although not that much. We will use atomic values within our tests, and we will write some tests. We will build our client inside of the test. We will test for race conditions. We will learn how to fix race conditions and how to handle concurrency using channels. And this video is not super mega polished like a lot of YouTube videos where the author is not making even a single mistake. I will be doing quite a lot of mistakes, and I think this is good. At least I prefer this kind of videos myself, when I can see that the person is making mistakes and I can learn from his mistakes and avoid them basically. And I can see the tricky parts in the language, right? So expect some mistakes in this video. And lastly, who is this project or video for? So it's not for complete beginners. If you've never seen Golang in your life, probably it's going to be a bit confusing. So I expect you to have some understanding of what are channels, what are coroutines, of core concepts of Golang. And I think it will be ideal for someone who has this knowledge and wants to put in practice and have build the skills how to handle concurrency, test for race conditions, how to use channels, how to use mutexes, etc. And then use the skills in real projects or at the job. And lastly, I want to mention that if you enjoyed the video, please subscribe to my channel. I would appreciate all the comments, positive, negative. Let me know how I can improve my videos. And yes, with the intro out of the way, let's jump into coding. All right, so I have only main.go here. As you can see, this is the start of our project. Let's create a function main. And actually, let's initialize our project go mod init. And I already have a repo for that. And by the way, link to the repository will be available in the description. Go mod tidy. All right, we will need. I will use a Gorilla package for WebSockets. We're gonna use it for establishing connection, right? But the rest of it, broadcasting, rooms, workers, will be done by us. So it will be at github.com Gorilla WebSocket. If I didn't misspell, and it seems like I didn't, it should work. All right, so what should we do? Let me just outline some to-dos. So the first thing we need to do is to create HTTP server, and we need to upgrade it to WS once client is connected. Then we need to add client to server. We should be able to remove client on disconnect. And we should be able to send broadcast message. And this might be no race conditions, right? We will test for it. And in here, before adding removing, we will add the client to a server, add new connection, newly connected, right? Newly connected WS to server, and add WS client. So someone who can connect to our server. Right, now let's do this. So the first thing we need to do is actually create some struct for our server. We will just call it server. In it, we will have clients. So we need actually to create clients first. Client, and what we will have? We will have ID here. It will be some kind of string, and we will need a mutex here. You will see a bit later why. So this will be sync read write mutex. We will use only read mutex when we will be looping over all the clients to send them messages. We will need to use it. Basically, I will write a test with race condition, and yeah, basically we will get race condition if we are not using it. All right, so here we will have clients, and we will send message to all these clients when we are doing a broadcast, right? So all the clients who connect, and then we send message. When we send broadcast message, we will send to every single client except the one who is sending, right? We will filter him out. So this will be a slice of clients. What else we need here? Here we will have mutex as well. Actually, client might not need mutex, but let's keep it in the client for now. And what else? For now, I think this is it. Let's create a function. Oh, actually, client will have a connection, and this will be pointed to WebSocket. Where is it? Gorilla WebSocket connection, right? Because every client must have a connection into which we will be sending messages. All right, new client. And this client will take this connection, WebSocket con, and it will return a pointer to a client. And let's write it out. So this will be client. And let's create an ID. I use a crypto package. So rent crypto, and here we can make text, and it will generate text. As you can see, it's described here, and we don't need such a big, so I slice it out to like 10 characters. So ID will be ID, then mutex, we will create new, wait, if I can type it out, new read write mutex, and connection will be connection, right? So if you're not familiar, new creates a pointer, right, to a mutex, to a whatever we're passing, right? So we are passing here sync read write mutex, and it creates it returns a pointer to it, right? You can check it out here, allocate 0 value of the type, right? And returns a pointer to it. All right. So we have server, we have clients, and now let's actually start adding the server. So HTTP handle func, we will handle, I don't know, under just slash, whatever. And yeah, actually before that, let's make a new server. It will return once again a pointer to server. And here we will have clients, right? It will be just an empty slice for now, and mutex will be the same. I will just snatch it from here. All right, and now we need to add a handle func. So this will be function handle ws, and here, let me just check what we need to provide. So the handle func should take this function with these arguments. Let's copy them. Right, so it will take these parameters. So this will be response, and we need to add this is HTTP, and this will be request writer. This is a common terminology, RW, right? You can name them whatever you like. So we have response, request and response, and now let's add handle ws here, right? And here we will create new client. Actually, let's do this straight away. Okay, let's move one by one. HTTP server first. And so we added handle func. Now we need to add some kind of listener, which will listen to our, at some port. Let's create a actually var here, ws port, and it will be 3223. I don't know, whatever. And it should be just equals. And here we will log fatal HTTP listen and serve, on WS port, and handler, we don't need any handler, so we will provide nil. All right, so what does it do? So we are creating here a HTTP server at the TCP port we provided, right? And it returns an error. So if there is some kind of error, right, we will log fatal out, and log fatal will OS exit 1, right? So our program will terminate automatically and log the error. And this is perfect for us, right? If our server is not working, if not listening, we're just terminating right away. All right, so the first thing is done. Now we need to, so whenever someone hits this route, just slash, right, we will run this handle WS, but this is going to be just regular HTTP, and we need to change protocol to WS. For that, we need to create an upgrader, which will upgrade it to WS. So Gorilla has an upgrader, and here basically we need to, I usually specify buffer size like 512 kilobytes. Is it in bytes? Should be in bytes, right? Your buffer size in bytes. Yes, in bytes. Yeah, wouldn't be in kilobytes. Just making sure, right? I never checked it myself, but I assumed it. So we will write buffer size the same size, and we need to make sure that we are not checking, basically check origin, right? We will just return true here, right? We will allow anyone, because this is a local project for now, but later on you can add some domain, right? Some validation. Nevertheless, now we have upgrader config, and now we will hit an upgrade function on it. And here we need to provide our W and our R, right? And did I, oh yeah, I mixed them up. Response writer and request. What is wrong? Oh, there's something else, and header, right? The last argument is nil. All right, and what does it return? It returns connection and an error. Let me just remove that. So we're getting connection and error, right? So now we have our WS connection, and the only thing, if error, right? What should we do if we are getting error on upgrade? We should probably, right, for now, we will return from this function, and I don't know, let's just log an error. I will think about it a bit later, right? Error on HTTP connection upgrade. And here will be an error. Let's make it actually we can return obviously HTTP error here. Let's do it like this, and /n. All right, and we will return from this function. So here, what we need to do, we need to add client to server at this connection, right? Somehow, and we need to start reading messages, right? Read message loop for each client. So each client, we connected it, right? And now it accepts, we will read messages from this connection, right? Whenever client sends it. And here there are some tricky parts, right? So we did the upgrade. Now let's think how we can add the client. So we have just a slice, right? The straightforward thing is we will create a client. So our client will be new client, and we will provide connection, right? And now we can just say server. Oh, actually, let's make it on the server. Let's make it as server. Then we will say that as clients will be append clients, and we will append client, right? What is that? Client. And this will be already a problem, right? Here we will get a race condition because we are updating the same slice. We can be updating the same slice in parallel, right? Because multiple requests can come in at the same time, and we will be updating the same memory, basically, in parallel. And here, let me adjust. We will create a new server, and this will be s.handlews. All right. So, and if you're unfamiliar, right, you can think of, if you're unfamiliar with structs or first time looking in Go, probably this is not the best course to start, but nevertheless, a struct, you can think of it, if you're coming like me from JavaScript, this is something similar to, as an analogy, right? They are not the same. This is analogy to a class. And if you want to assign some method to this class, right, this is how we do it, right? You specify which struct first, and then we specify which arguments, and the rest is the same, right? Just a regular function. I just wanted to mention this because I would assume that a lot of guys who's going to be watching this are from JavaScript land. All right, let's actually, I think now we can add WS client and test it out and see if we will get any race conditions. Let me just close all of this for now, and actually let me create a makefile. And here I want to add a few comments. So we will build our project, run our project, and run tests with race condition. So the first one, let's add build chat command, and this will be go build -o, and we will build it into bin folder, and we will name executable as chat, and we will build everything that is here, right? So here we are specifying where we will build it, and here we are specifying what we will build. Let's test it out, make build chat. All right, and let's take a look. And as you can see, it's in here. We also need to make sure that, just in case, we provide all the needed permissions. So let's add chmod +x and to this file bin chat. And now let's run it, right? I will just name it chat. And so we will run build chat. And then we will just run our executable. Right. Let's test it out. Actually, let me add some kind of logs at least. fnt print f. Right, so we will log it out. If we will get an error, we will straight away, right? If there is an error after this line, we will get an error. All right, so we are starting server on port. As you can see, it's working. All right, and now let's, so I will create our client straight away within a test. And yeah, because we don't need it otherwise. And I have a simple web server or client as well, but we're not going to use it for now. Later on, I will use it just to make it more pretty and understandable. But for now, since this is a Golang practice, let's use Golang to connect to our server, because why not? All right, so let's add something like test chat race. Okay, so first thing we need to run, I already know it from my previous live stream, we need to clean cache. Because it wasn't clear to me why the tests were running all the same, and turns out in Go this is like a common thing. And then we need to write go run test with race v for verbose, and we will run in our bin. Actually, we will run everything here, right? And yeah, now let's start adding tests. And the great thing about Go that it's very easy to write tests. So we just need to have a naming like this, main_test, and then the tests will automatically pick them up. Right, understand that this is a test. So what we need to do here, we need to write some kind of function, test connection, and it will be taking t from testing, not testing dot t. We don't need that. And here we can write our logic, right? So what we need to do, we need to create a client that will dial, right? Okay, let me just write it out. So we need to create a dialer, which will be once again from Gorilla, and let's make default dialer. What is that? Full dial. Oh, we don't need that, and we will just connection, and I think error will be dialer.dial. And here we need to dial to fnt sprint f. We need to specify the whole URL, so this will be ws local host, and here we will provide the port we have. I mean here string, and here will be our ws port because it's available. And what else we need to give here? Dial, we need to request handler, we don't need that, and it returns connection, response, and error. All right, so response we don't need as well. So this will be an empty thing, and like so, right? If we get an error, we'll just log fatal. Should be fatal here? Probably yes. We should terminate the test if we're unable to connect the server, right? Yeah, it means that the server isn't working. And now we have a connection. So we will create a coroutine. That will in for loop. Actually, we are done for now here, right? Because we don't need to do anything else once we get the connection. Print line connection, does it have some kind of ID? Let's get the local address. Something to understand that we indeed connected. And actually, let's move this to a separate function. And here we will have some kind of struct with test config. And here will client count, because we want to test how many clients, I mean, we want to test race condition, and we shouldn't connect a single client, right? We will have some kind of test configuration. So let's make tc will be test config, and client count, let's say 3, right? And then for each of these clients, tc client count. Well, we don't need anything here. We can just range over them because we don't need index. We don't need anything. We will create a coroutine, which will dial server. Like so, right? So now we will create 3 coroutines, which will concurrently, right, dial the server. And so let's start our server. As you can see, it is listening. And now let's run the test. And as you can see, test is passing. Everything is fine when we running tests as normal, right? But now if I will create another terminal, we put it on the side, and here we will execute make, how did I name it? A test chat race. Okay, it's passing as well. Of course, it's passing because, yeah, we are just exiting from the test and everything is good. Right, so we need to add some kind of wait group here and make sure that all the clients connected, and then, right, and then disconnect. So we will add wait group for that. So this will be pointed to sync wait group. And here we will have vg, which will be new sync wait group. Now in we will add all the, this will be as well tc we'll add all the entire client count, right? Here we will add tcvg wait, and now we need to say when we are done, right? If you're unfamiliar, so wait group, what does it do? So we added count 3 clients, right? And only if we decrement the count to 0, then we will be able to pass, right? It will be stuck here on the wait until we have the client count of 0, right? So we increment it to 3, and the wait will block further execution of our main Go routine until the count runs to 0. Actually, let me print it out. fmt println exiting test, right? So we can see it. And here we are actually not doing anything. We are connected, and here let's sleep for a second. And then we will trigger connection disconnect. Connection close, I think, yes. And after that we will run. Okay, we need to pass VG here. Actually, we will do it in defer to make it pretty. And we will move it here. So we will close, and okay, we don't have connection at this point. We will move it into here. And we will say that VG is done, not add, done. Right, and when we are hitting VG done, it will decrement, as you can see, at -1, right? It's the same. So we're decrementing by 1. So every time we dial our server, we will sleep, we will connect to it, we will sleep for 1 second, right? We will block here, then our function will exit. On the function exit, we will close the connection, and we will hit done. And once we hit 3 dones, we will be able to continue, right? And we should see the log exiting test. Right, let's dial server, and here we need to provide tcvg. So let's once again run the test. Timeout. Okay. The server is not accepting connections. Let's fix it out. Okay, so we are upgrading. We are connecting. If connection... Actually, we didn't get even to the error, right? Do we have handle func? Yeah, there are no errors. Let me check our server. So we are dialing. Okay, this is the error. Local host. Let me move this to some kind of variable so I don't make similar mistakes. Host will be something like this. And this will be actually we need to move this logic into separate function. Let me just let's make web7, and here we will run. And why we need this? We need this in our test as well, because actually we need to run it not from separately, we need to run it from test, otherwise how the test will know if we have any race conditions, right? And here, just for simplicity's sake, I will sleep for like a second for our server to start up. Time second. All right, now let's check the tests. Actually, now we no longer need the first terminal. We need only second. And I noticed that was a bit cut. Let me just put it here. All right. And oh, actually, I've noticed that it shouldn't be in the dial. It should be in the test itself. Right. Otherwise, we will be creating this for every single one of them. All right. Let's just, test the regular test. See how it's going to go. All right, we are creating connections. So the test is passing, right, with 50 connections. And now let's test the race condition. and it failed, right? So the previous one passed, but the race condition now is failing, and what we're getting data race. And where do we get it? Right, it's because we are writing here in the same place, right? So if you will take a look, example go main 62, line 62, right? So we got this error at the same place. So how can we fix it? So the easiest approach would be just to lock it here, right? So we will s mu lock, and here we will s mu doesn't want to suggest me unlock. Okay, we will do it like so, and let's try it out. And the test is passing now, right? Amazing. But if we remove lengths here, right, it will get race condition again. Yes. See, a small thing like this violates. So what is the problem with this approach? And actually, I don't think there is a problem, but yeah, in Golang, there is a phrase, a common one: do not communicate by sharing memory, instead share memory by communicating, right? It's on the official Go blog. And right here, actually, they're showing the example where they're using mutexes. Obviously, the example is a bit different, but nevertheless, I read several articles and I was gathering information about that. And luckily, I have some way more experienced teammates at my company. And they said that all the solutions like this should be handled via channels. So we need to share memory by communicating. In other words, we need to create channels here and handle new clients via the channels. And they said if you have a small number of clients, it will be fine, right? But once you have way more, you will suffer performance problems because of the locks. And I don't know if that's the truth, right? I trust them for now. But I already, in my live sessions, I started running performance test, and I will actually measure it to see how it's going to work. But for now, actually, locks are very easy, right? So let's do something more complex, and it's not going to be way more complex, but let's add the channels. Let's do it the right way, right? So what we need to do, we need to add channels first of all to our server, right? And let's add join server channel, and this will be channel of client, right? So once client connected, we will join him to the server, we will send him and leave. And we need somehow to make this sequential, meaning we need to add some kind of queue, right? So every client connected will be processed one by one. They will not be handled concurrently because otherwise we will have race condition once again, or we need to use locks. So how can we do this? For that, we will create for loop. Let me just snatch the function. So we'll create something called, I like to call this a sept loop, right? And we will create a select statement. And in select statement, we will be waiting responses from those channels, right? So the first one, the first case, right, we will be waiting for a value. Let's say client will be equals whatever comes from server. What's the problem? Let's make like so, from join server, right? And the second case will be once again client, which will come from as leave channel. And here we will handle join logic, right? And here we will have handle leave logic. Right, so what does select do? Select evaluates all these cases at the same time, right? And it will be blocked until one of these cases can be executed. So until we receive something in one of these channels, select is doing nothing. Once it receives one of them, it will exit, right? So if nothing is here, it will be blocked. If we will add, for example, default statement here, and here is nothing, and in this channel is nothing, it will just execute default and exit. And this is perfect for us because it is waiting for one of the responses, for the basic response from one of these channels, and it will process only one. So essentially select already acts as a queue. The only problem is that it will execute only one operation. So for that, we will create an infinite loop. And this infinite loop will handle the select statements. So as soon as message arrives, for example, into join channel, it will process a join channel, and we will get into the next iteration of the for loop, and we will be checking again, do we have leave, do we have join? And as you can see, we will process every single operation one by one. And this way, we are avoiding race conditions. All right, now let's actually write join and leave server logic. I hope this is clear. If it wasn't, let me know in the comments. I will try to dive deeper because this topic is quite, well, I can talk a lot about this, right? It will take a while. But you got the point. Essentially, we are creating a queue here, and I'm not saying any default statements. And as you can see, I'm not doing this in Goroutines. Well, I'm not going to be handling in Goroutines join and leave, so we will be handling them sequentially. All right, let me snatch once again the function, and here we will add join server, and we will receive client, and all we need to do is server clients, and yep, we'll append client, and that's it. And another function will be, okay, let me just copy it. And here we will write delete from s clients, we will delete c.id. Oh, clients is not a map. Did I make it? Oh, actually, this should be a map of string and clients. I'm not sure why it is like so. Yeah, we will remove this part. We have new client. We will remove this, and here we will just server join channel, and we will send the client. And here not append. Here will be clients c.id will be equal to c, right? Like so. Yeah, it should have been a map. And here let's just add a log, actually fmt println client joined the server. Actually make this printf, and we'll make cid equals, and here will be cid, and here client left the server. All right, and now let's add here as.join server, and we will pass in client join server, and here as leave server, and we provide client. All right, and now we need to start the loop. And also, I think I didn't create the channels. So make channel, I'll create, I don't know, some random number, 64 bytes. And here, leave channel the same way. All right, this should be good. Now let's test it out with the race condition. Let's make a fewer clients. Let's make just 5. We got only one client join the server. Not sure why. Should get all 5. Let's debug it. First of all, let me adjust the logs here. So they are starting from the new line. And I have a feeling the problem with how long we are sleeping. We are just leaving, we are disconnecting too fast. Let's test once again. Yes. All clients connected. Joint server connected to exiting test. I don't see that we left the server actually. And yeah, I have an idea. It's because we are actually not leaving the server. Yeah, this is the next thing we're gonna do. So the good thing is we didn't see any race conditions, right? Let's run it once again. As you can see, we are connecting. All the clients connected and the test is passing. So no race conditions. We are handling everything sequentially. Let's make a client count to 50, 50, and let's run it once again. Make sure. Yep, we are passing the test, right? No race conditions. Amazing. Now we can continue with our logic. So let's mark our to-do, add WS client, done, add newly connect to the server, done. Remove client, disconnect. Now we will add disconnect and then broadcast. Okay, let's do this. So we'll need to add to our client a read message loop, which will trigger on handle WS. So let me take the client, and this will be a function on our client. Let me think what it will take. It will take the leaf server channel, and this will be a channel which accepts, which will send a pointer to the client, right? And it will not return anything. And here we will have an infinite loop, right? And we will continuously read from the client's connection. And here we will have read message. And let's take a look what we are getting from it. So we are getting message type. We don't care about that. We're getting bytes of what we are reading right from the connection, and we're getting an error. All right, so the first one we ignore, then we're getting bytes and error. And here, if we are getting an error, so this is the scenario when we should disconnect. I mean, if we got an error, we should leave the server, but probably if we are getting error, we are disconnected, or maybe there is some other error. So we will anyways add a defer function. And for now, I'm writing function because I think we will add more into defer. So here we will run anyways c.connection.close, and close returns an error. So if client was already disconnected, we will run it again. We will get an error here, but we don't care, right? We will just as a additional layer of protection, right? But if we're getting an error here, we will just, I think, return. Right. Yeah, we will just return, and here we will send into leaf server channel, we will send our client, right, to disconnect him. So we are returning, we will exit the for loop, and we will trigger the defer function, which will make sure that we are closing connection, and we will leave the server. All right, but if the message is valid, we assume that it's going to be of the specific message type. And for that, actually, let's add a message. So I will add a type message type. This will be a string, and we will create a constants. I like to prefix the constant with something like that. So we will add a broadcast, and this will be of message type, and the message will be broadcast. All right, later on we will add more messages, message types, and we need to create a struct. So this will be request message. Yeah, so it will have a message type of type message type. Then will we have an ID? Probably not, no. So we will have a client, which will be pointed to a client, and message type. And yeah, we will have just data, and data will be string. So the message which is being sent to us. So it's going to be a string format. Obviously, it can be something else, but for now, we will just handle strings for simplicity's sake. And I think for now, this is it. So we will take request message, and we assume that our client will send us this request message of the same format, right? So we are able to parse it. If not, then we will just ignore it. So let's create this message. And we will create once again a pointer to it straight away. And now we need to parse, because right now we are receiving bytes and we need to parse them. So for that, we will use JSON package, and we will unmarshal. So this is if you're from JavaScript, This is the same as JSON parse in JavaScript. So we will unmarshal our bytes into what? Into message, right? And here we are getting an error. So if once again, if we are getting error here, it means that we were not able to convert, basically to unmarshal our bytes into this message. So it's some kind of different format. And here we will just continue the loop and I will log it out. Printf. All right, otherwise we got our message and now we need to broadcast it to everyone except the client who sent it. And for that, we need to send it to broadcast channel. And now I think we should actually provide the entire server here. I will create a server. I mean, this violates some solid principles, but nevertheless, I am a bit lazy to provide one by one all arguments. We will just provide the entire server. And now on the server, we need to create a broadcast channel. Sorry for the violation of solid principles. But nevertheless, that's not the point of the video. We are learning Golang, so we will do a little bit of dirty coding. All right, let's do broadcast channel. Why didn't I copy it? Okay, broadcast channel, and we will send through it a message, request message. And yeah, I think this is it. Let's go back, and here we will take our server, broadcast channel, and we will send the message into it. And now we need to, first of all, in the VS handle, we need to run our message loop, right? Let's delete this, let's delete this. We send that the client joined, and now client, and we will read message loop, provide the server into it, and we will run this in Goroutine. And this is just S, right? So we are starting Goroutine with infinite loop. If we are getting a message, we are leaving this loop, and we are closing connection and sending that client should leave the server. Otherwise, we are sending it to the broadcast channel, and let's actually, in the server's accept loop, let's add the case of added too much. And here will be broadcast. And let's add the broadcast logic. For now, it's going to be just a dummy one. Actually, let's add straight away everything. Broadcast, it will take in message, which will be pointed to request message. Once again, we are not returning anything from it. And here, okay, let's test out the logic for now, just to make sure that everything is working. I have an error somewhere. Yes, because here we need to send a message, and this will be message. And this is not leave channel, this is broadcast channel. All right, now let's check out our test and make sure that we are leaving the server, right? So we are given 2 seconds, then we should close the connection and we should leave the server. And let me add a small timeout here. I mean, sleep for a bit to let the clients actually disconnect. And we should see that the clients are being disconnected. So we will add 1 second for and here we can actually remove this log already because we can see that the client has been disconnected. Let's just run the test and see how it's going to go. All right, so we got the client left the server, but I think we were having like 50 of them. Let's just have 3, so we can definitely see what's happening. So 3 clients joined. After 2 seconds, 3 clients left, and we exit in the test. Amazing. Now let's test it with race condition. Okay, I have to restart my terminal. Let me copy this. Okay, we don't have any race conditions, and obviously in our test I'm adding sleeps, right? We can make it much better, that we know exactly when the client's left. We will do it a bit later, but for now I'm just making a very simplified version just to see that our server, client, everything is working, right? Let's make 10 of them. Just making sure, all good, right? Test is passing, all good. No race conditions. So as you can see, as I said, this entire thing acts like a queue, and so far everything is working. And actually one of the important parts, we will broadcast in a Goroutine, because in Goroutine we are not adding anything and not removing from our client's map, so we don't care. We can do it in a separate Goroutine, not to block, join and leave from the server. All right, but now in the broadcast we will actually use read lock, because we can be, since why am I doing broadcast in a separate Goroutine, right? Because we can have a lot of clients, and if we'll be doing this sequentially, this can take time, right? This procedure, or broadcasting, sending message over the wire to every single client, right? It may take time. So I don't want to block addition and removal of clients, right? So someone disconnected or someone wants to connect and we are blocking them while we're sending broadcasts. So this is not very nice. Sorry, my phone rang. All right, so for that, we will actually use the lock. Actually, should we test without the lock to see that it's going to be race condition? Okay, let's write it with the lock and then I will remove it. All right, so we will loop through, not message, we will loop through the clients, and we will create actually client's copy. So this will be once again a slice of client. And here we will have the client, and if client ID is not the same as the message client ID, right? Because we don't want to send a message to the client who is broadcasting, right? If it doesn't equal, then we will append him into this loop to send. Otherwise, we are just continuing. And we will need to wrap this into mutex, into read lock. And we need only read, right? Because we are not doing any writes, and just our lock, just in case, right? It's a read lock, and it's going to be more performant than write lock, obviously, and we don't need any writes here as well. And what's the problem? And never used. Okay, we will use it now. And now we will use, we will loop over these clients actually now. So why we need to do this, right? Because at the same time, some clients can be removed or added, and we just want to make a snapshot. So it's not going to be something, not going to get garbage collected or whatever, and we will send a message to all of them. In case if they were disconnected already, we will get an error and we will ignore this error. This is fine. Otherwise, we will not get any problems that client disconnected, connected, and we are somehow sending at the same time messages to the same connection, right? We can get some kind of weird concurrency issues, and I was having them. So if I'm making like the exact snapshot, everything is going to be fine. And we will test it for race conditions without the lock right now as well. So now we will take C connection and we will write, let's actually write JSON straight away. And actually we need to create a response message. We have a request message. Let's create a response. It's going to be very similar. We just send the same message, message type, client. We will remove client. We will just have sender ID. And this is going to be string, and we will add a function which will create a new response message. It will take the original message and it will return a pointer to response message. And we will return response message. So message time will be message type. Data will be once again message data. We will just send the same message back, and sender ID will be message client.id. Right now, let's go back. Some reason it doesn't want to send me back. Nevertheless, let's create a response. And this will be new response message, and we will provide message, and we will write JSON response, right? And write JSON, what does it give us? It gives us an error. So if we have an error, we will just continue, right? So this client, for some reason, we are getting error with it. We don't know why, but we will print out the error. All right, and actually, if we got an error, the client could have disconnected. I'm thinking, should we drop him? I think not. This is going to be an overkill. In our read message loop, we are already dropping the client. So if client will disconnect, we will disconnect them in the read message loop. I mean, in here, I'm just thinking, if we're getting error on sending message, should we disconnect there as well? I think not. All right, and here let's just fmt println that broadcast was sent. All right, so how can we test it now? Let me just close what we don't need. All right, we have our dialer. Here we are sleeping and closing connection, right? We will remove this part. Actually, let me just comment it out. Maybe we will use it. So here we will create as well a for loop, an infinite for loop, and we will read messages which are being received from the client. So pretty much the same, right? Bytes error will be connection read message. And here we will not check for the message specifically, we will just check that we received it. So if error, we will return, right? And we will trigger disconnect and done. Otherwise, I think we need to add some kind of counter just to know that we received the message. So let's add in our test config broadcast message count. And this will be, here we will use atomic value because we will be receiving these messages concurrently, and we need something for which is concurrently safe, and we don't need to add logs here. This is just a simple counter, and for that we have atomic package, and here we will add int 64, and we will just increment it like so. So if basically we got the message here, right? Let's just make sure that it's not a blank message. So if length of b is greater than 0, right? Then we will increment our, do we have config here? We are just having wait group. Okay, let's pass in the entire config here. Tc test config, and this is going to be tc done, and here we will do tc broadcast message at 1. We will increment it by 1, and let's have some kind of target, target message count, and this will be just a regular integer. And if tc target message count is the same as tc message count we are loading what we received, right? If they're equal, we'll just return from here, right? We reached the required message count, and we will exit this for loop. We are not expecting any more messages. And should we wait? I think we don't need to sleep anymore. And in our test config, here we will provide the entire tc test config. What's the error? I need a pointer. Yes, all right. And now we are waiting. Now let's add the actual test. We'll sleep for a second just to make sure that everyone is disconnected now. And here we will once again create an infinite loop. And I'm just thinking we will actually sleep in the loop. If once again we will do the same check. Although we are waiting already here. Yeah, I don't think that we need it. Let's test it out. So we need to add in our test config, we need to create atomic int64. And actually this should be a pointer. Right. And here will be target message count, and target message count will depend on the client count. So let me actually client count will be 10. Let's make it like 5 for now. And here we'll pass in client count. So we should get messages. So it should be our client count -1, right? Because the client who is sending, he will not be receiving the message. And we need to add some kind of broadcast count. So broadcast count, how many messages this client will send. So broadcast count, let's say, I don't know, 3 for now. And actually we need one of the clients who will be broadcasting, right? We need to create him in advance. So we will take broadcast client. He will be equal to dial server. And we will be doing this in Goroutine. Let me just think about it. Yeah, we should do this in Goroutine, and we will be not returning here. We will create an exit channel. Let's make it exit of struct. And this channel we're going to use to signal that we should close. Well, actually we will remain the return, but here we will close exit channel. And the same here. So if we reach the required count, we will leave this Goroutine. And now we need to block here on exit. So once we close the channel, we will receive a message here as, right, it will block until we close this channel. Once we blocked it, we will close the connection. We will hit done. And once enough done's been hit, we will release this wait, sleep for a second just to let our clients disconnect, and we should exit the test. All right, we have broadcast client, and why I did this, so we can return actually from here client. WebSocket connection. And here we will return connection. And now we have our broadcast client. So we create, actually now we will have +1 client, right? In a for loop, we will create all the clients which will be receivers. This will be a sender. And once again, we will create a Goroutine. And this broadcast client, let's actually, this is going to be range over broadcast count. And we don't care about index. Actually, this is going to be a range, and in a range, we will do Goroutine stuff. So here, and not broadcast, this is going to be broadcast client, not close, write JSON. And here we need to create a message. So this is going to be, do we have new message? New response message, we need to create new request message as well. Actually, request message, probably we don't really need it. Okay, we will create it like so. So we will have message type, and this will be broadcast. We will not have client, but we will send data. Hello, let's just, yeah. Hello from test. Right. And we will provide here pointer to this message. And I think we should be good. Let's just make sure if we are getting error here, we'll just log it out. We'll return from here. All right. Now let's test this baby. And this is not printf, like so. Let's save everything and let's run the test to see that we don't get any errors at all. Client J the server, so I'm blocking somewhere. Okay, so let's take a look. What am I doing wrong? All right, so maybe I'm messing up something with client count. Okay, so here, first of all, +1, right? Because we are adding one more client. Let's have a look at the dial server. So we're dialing and we, oh yeah, defer. So this should be in a Go function now. So we will create a separate Go routine, which waits for exit and it will trigger done, right? And we will trigger exit manually right now, and it should work. Let's try it out without race condition for now. Okay, and when you'll point at the reference, where in 150. Oh yeah. We are not assigning the message to anyone, right? Where is our read message loop? So here we are creating message. If we all good, we will say that message client is C. Right, and now let's test one more time. So still we're getting error. Concurrent write to WebSocket connection. Okay, yes, I know what is the error, right? We are writing it into this connection at the same time. So this is something we need to fix later on. Basically, we are not allowed to write it to the same connection concurrently. And to fix concurrency, obviously, as you might have guessed, we're going to use channels and we're going to use for loop with select. So we're going to synchronize it essentially. But for now, let's just make sure that everything else is working. So for now, I'm just going to sleep. And actually, I realized that we need to sleep here just to make sure that all clients connected. And here we're going to sleep just for like 100 milliseconds. Just to test it out. And let me actually review a bit more the code. Okay, here another mistake. We need to multiply this by broadcast count. So target message is number of clients and number of broadcasts, right? And here we're adding one more client. All right, this is good. Actually, yeah, I think this is another error. We will never reach this point because once we send all the broadcasts, we're not going to be checking this ever again. So we need to make it in a separate Go routine. And actually here we need to create as well a for loop and set like time sleep, because I don't want to, we should not run it like non-stop. We will just run it every like 2 seconds. And then we will check if we reach the required message count, then we will close exit and then we will return. Once we close the exit, we unblock here. We are closing connection. We will get an error here and yeah, we no longer need to close the connection. We will hit done and it will continue our test. All right. And actually let's unlike the VS Codes thingy, let's just write separate run test. We're going to do it via the terminal. So let's do the make test chat. Let's see what's going to happen. All right, still getting errors. Just look at the top of the error. Unlock of mutex. All right, where is the problem? Okay, it's here, right? So I was doing a read lock, but I was doing a write unlock. Okay, let's test it out and see if it's going to work now. So we are joining, sending broadcast, client left, and the test is passing. Amazing. And actually, thinking about it now, I think we can do it even without locks, right? We will do... we will actually pass in clients here from above. I will explain it now. So we will provide string client. And we will not append them. We don't need this part. We're just gonna send them there. And what we're gonna do, we will actually make a copy here synchronously without any race conditions. And then we will basically pass in the copy here. So let's make clients. This will be map string client. And we will for range over CLS. And this is going to be ID. And this is the connection. So we will say that client ID will be equal to C. And if ID is the same as message client ID, we will basically not the same, right? Because we don't want to send to the same person. We will move it here. And now we will pass in the clients in here. And what is the problem? The string client, and we need to initialize it. And this should be a loop over servers clients, right? Not over CLS, not over the same thing. All right, let's test it out. Okay, all good. Let's test with race condition now. Amazing, no race conditions. Let's just... Yeah, I'm sure it's fine, but just to be... Let's make it like 50 clients and 10 broadcasts. Okay, all good. No race conditions. Let's revert it back to 5 clients. And now we need to solve the concurrency problem which we have here, right? Because this time slip is not going to work with the actual client. And actually we need to solve the same problem with the server, because broadcast can be broadcasting into the same client concurrently. And for that we will create, we need to create channels for both client in the test. I mean, this actual like web client, which is going to be on a website somewhere, and the server. Okay, let's start with the server side. So we need to make our client smarter, and we will need to create a message channel here, which will be response message, not response message, which will be channel of response message. And let's create a message channel. And let's assign it once again 64 bytes. We used to do before. Let's snatch this function out and let's provide it here. We will not need server here, and this is going to be a write loop. So what we're going to do in this write loop, and we need, I think, some kind of done channel. Let's just name it done, and this will be just a struct to signal that it's time to exit. So this is going to be another for loop with select, and here case if we will get done, right, we will just return, and this is c.done, and case if we are getting message, this is going to be from our c.message channel. Here we will be writing into the connection, right, and if we are done, I think, right, we will close connection here. So we will do defer connection close in here. And in here, we will close the done channel. We will do it like so. So if we are getting any errors, right, we are exiting read loop, we are closing done and leaving the server. And while this is happening, we are hitting return here and we are closing the loop and leaving. Should work. Yep, should be good. Now let's go to broadcast and let's snatch this logic out. And here we will be, what we're gonna do, we will just say channel, message channel, we will send response. Where is the problem? I need to send a pointer, right? Send a message channel. Actually, no, here is the error. All right, and now we will add it here. This will be message. And if we are getting any errors, we will return here, right? We should not just continue the loop. If we have an error, right? If we're unable to write into connection, something wrong with the connection, we are just exiting the loop. We will not keep it. All right, and now we need to have this loop before our read loop. All right, this is good for the server, I think. Double check. Yeah, all good. And now we need to do the, let's actually double check it. We didn't break anything. Okay, broke something. Close of nil channel. Okay. Yep, I didn't create the done channel. Make channel struct. Okay, all good. No race conditions. Amazing. And now to the test side. So we need to create the right loop here as well, but we need to create some kind of struct. Okay, let's put it on the top. So this is going to be, I don't know, test client. He will have connection. This will be WebSocket connection. What else here? For now, I think this is it. Let's create a func new test client. It will take this. Let me just copy it. Connection, right? And it will return pointer to test client. And here we will add type as well. Test client and connection will be connection. All right, what else we need here? We need message channel. This will be a channel of request message. Right, so message channel. And once again, let's give it some buffer. Anyways, we will process it synchronously, but just to be sure. And we need a done channel as well, which will be struct, so we can close this loop. And done channel. And yeah, I like the autocomplete of VS Code. All right, so we have test client. Now we need to create it in our test. So we're getting, this is not going to be, let's name this broadcast connection. So this is going to be the connection that is sending the broadcast, and now broadcast client will be a new test client, and we will provide broadcast connection. And now we need to snatch out all this logic. And here we will just set that broadcast client and message channel will receive the message. What's the issue? Request incompatible types. What did I do? And this should be pointer, right? Yes. All right, now let's create a function a loop for that. So let's just put the loop in here, and this is going to be our test client. It will be once again write loop, loop. And here we will create once again a for loop. We will select if we are getting done. See that done. If it is from message channel. All right, and we will send it to C connection. And once again, if we're getting error, we will return. All right, now we need to start the client. So once we create broadcast client, we will create write loop, and this will be in Go routine. Okay, and now we need to somehow provide done. So we need to hit done somewhere here. So we need to provide it in advance here as an argument. Okay, I don't think it's a good idea. Let's actually do it with via context. So we will create context and cancel, and we will have a cancel function. Context dot context with cancel and context dot background. All right, and we will assign this context to our client. And we will hit here cancel. I will just type it out and explain how it's going to work. So here we will have ctx, which will be ctx. And here will be ctx context dot context. And we will have the same here. All right, we are providing context, and now here we will be waiting not for the done, we will be waiting for ctx done, right? So essentially context, right? It has a cancel function. I created a context with cancel, and whenever we hit cancel, once again it will signal to all everyone who is listening, right, that it is done, and we are catching this signal, and essentially will return. Pretty much very similar. Now we don't need the done channel anymore. Just slightly different approach. And let me check it out. What's wrong here? All good. So now we are looping our account, sending message, waiting, canceling. Here we need to wait for a second just to make sure that client's connected. And here we're just waiting to disconnect them. Okay. Let's test it out. Okay, all good. No race conditions. As you can see, we no longer have a timeout. We are just sending message into the channel once again and processing it in the, where is it? In the loop, right? So we synchronize server and the client, and on the server it's the same, right? In case if we are having any issues, like a client is taking longer to write some message than the other, right? It's absolutely realistic scenario. We will have a separate loop for every single client, and they will write as soon as they can, right? And essentially, yep, this is a way to handle concurrency in Go. And I think, yeah, probably this is enough for this video. In the next one, we will work with the rooms, and yeah, we will write test for the room as well at the client. Let's just test it out with like 500 clients and I don't know, 100 broadcasts, just to make sure that didn't broke anything. Okay, test is passing, all good, no race conditions. And we know that we received the correct message count, because in here, right, unless we receive the exact message count, we will not close and exit the test, right? Test will be stuck. Obviously, we can do it a bit differently, right, add assertions here, but right now I can see that it's working. All right, I think this is it for this video. We will continue the next one with more rooms. Probably we need to add ping pong. Yeah, I will think about it as well. We can do a lot more things here as well. So for example, in the next videos, we can do obviously send room message. We can do join room, right? Join room. Leave room. And send room message, and everything should be without race conditions. Then we can make sure that we don't have any memory leaks. We will do it using Grafana Prometheus. I already have dashboards prepared for my live sessions, and we can also test performance and see how it's going to work. Okay, this is the future plan. We will do it in the next videos because this one is already quite long. Right, I hope you enjoyed, and there are tons of interesting concepts here. I learned a lot by writing this code, even writing it now for the second time. Still, I'm making tons of mistakes and learning and improving. Like, I feel like I learned so much right now. Okay, thanks for watching. I will see you in the next one, guys. Take care. Bye-bye.